Okay, so this is going to be audio lecture, a very short audio lecture on another reading for case bundle number 5 called Design Principles for Industry 4 Scenarios. Now, when we talk about Industry 4 scenarios, this is a concept or rather an amalgamation of several things that are now becoming common within the industry. So, since this is a research paper, it talks about a lot of stuff that may be quite unnecessary for the course, but what we need to pick up from this is the concept of the Industry 4 and what it's all about. Now there's a lot of convergence of industrial production information and communication technologies that are happening at the same time. So lots of new technologies are being developed and they are now colliding and connecting and changing the field of industrial production, and this is what is referred to Industry 4.0, or rather the fourth generation of industry, right? So there's a fascination with the concept of Industry 4 because obviously this is the first time an industrial revolution has been predicted a priori and not observed ex post, which means that we knew that this was going to happen. We had an idea of this was happening. Otherwise, in most cases, it happened and then people looked at history and they said, oh, so this is what happened. Nobody knew when the steam revolution was happening in the industry that this was going to happen, right? It was only later they realized, okay, this was the steam revolution and there was the microchip revolution, that sort of thing. So it has had a huge impact because it provides a lot of opportunities for companies and research institutes to actually shape what is going to happen in the future. And secondly, the economic impact of such an Industry 4 is going to be quite big. So Industry 4 has become a top priority for many researchers to understand, many universities and many companies to understand, so as to realize how they can make use of it. So apparently there's a group that was created called the Industry 4 Working Group and the platform Industry 4 to understand the concept of Industry 4.0. Now, even though Industry 4 is one of the most commonly discussed idea, it is very difficult for most common public to understand what it's all about. So the authors in this particular paper have actually helped to understand the concept of Industry 4. So Chapter 2 of this particular article of this research paper actually introduces the idea, the vision and goals and the components of Industry 4, and it explains how it relates to the Internet of Things and the Internet of People and the Internet of Everything, and what similar concepts can be found in the remaining world. Now, since this particular article is mostly about the German industry, and Chapter 3 actually talks about the research process and methods, which we can totally skip. Chapter 4 talks about the design principles for identifying and implementing Industry 4 scenarios, which we will look at, and Chapter 5 actually talks about a case study on how these are actually implemented. So this is what it is, and Chapter 6 is of course the contribution part, since again it's the research paper. So let's look at Chapter number 2, which says the term Industry 4 is actually used for the upcoming industrial revolution that's about to take place, which is happening right now. So this industrial revolution actually happens after three of those industrial revolutions have already happened. Obviously, the first revolution was when mechanical production facilities were created, when machines were actually introduced that were mechanical in nature, and they were relatively they were powered by machine steams, and later on electricity as well. So this was intensified during the 18th and the 19th century, and from 1870s onwards, the electrification and division of labor, if you remember Francis Taylorism division of labor that we studied in Principles of Management, which led to the second industrial revolution, and then the third revolution, which is referred to as the digital age during the 1970s, when microchips and microprocessors and information technology became common. Now, Industry 4, as it's called now, is the term that was actually started to be talked about since 2011. Okay, so this initiative called Industry 4, which was all about the businesses and political elements, as well as the academia, which is the universities and youth students, involving themselves specifically in the German manufacturing industry. Now, recall the reason that we are discussing this from the aspect of the German industry is because, well, the Germans have the most powerful, one of the most strongest world economies right now, and they have been huge contributors of the manufacturing industry throughout history itself, because it was Germany, or rather prehistoric, in historic times, who actually came up with the printing press, which could be considered to be a huge milestone in the industrialization of the printing industry, right? It was in fact a huge milestone. Anyways, so it is all about the fundamental improvement of the industry itself. So how is it enabled? It's enabled by creating a sort of a network, a sort of a communication between the people involved, the machines that are involved, and the resources. So the fourth revolution is actually can be characterized by understanding that there's a shift from centrally controlled production processes to decentralized production facilities. So now there are smart products who know what they're producing and how they're connected with other machines, instead of just them being dumb machines. So the German government actually supports the idea of this, and they've been talking about it and focusing about how they will achieve this by 2020, which is, well, this year. So this particular publication actually talks about the concepts of that precise idea that the German government had. So the Industry 4 working group actually talks about integration of Internet of Things into a manufacturing process as an enabler of the fourth evolution. So what is the IoT? IoT, or Internet of Things, actually means that devices will talk to each other. That practically every device will have a network component to it, and they will connect to each other and will talk to each other. With talking here refers to communicating with each other. Think of smart homes and apply the same concept to industries. Now, instead of actually smart homes being something that are only used at the consumer level, we're talking about an entire factory working in a manner where every piece of production line and every equipment is in communication with others. So when a particular part is being manufactured by a particular machine on an assembly line, another part that needs to connect with it, and that machine is communicating with them. So there are RFID sensors, there are actuators, their entire process is being communicated with each other. This is referred to as the Internet of Things. So it is the fusion of the physical and the virtual world, and here we do not mean virtual worlds as in the virtual worlds as in augmented reality or virtual reality. No, we mean the digital world that actually is allowing machines to actually talk to each other so as to improve the efficiency of productions. Now imagine earlier in the Industry Revolution 3, or even the first one or the second one, people would have to coordinate between those machines. They would have to see whether components that are being manufactured by one particular machine and are on the production line can be attached or are ready for another component that was made on another machine physically right there, right? But now that doesn't happen. Each of the machines are communicating with each other. Every single item that's been produced has an RFID tag to be able to track where it's going. Think of the way that Webvan or even Amazon had their entire supply chains managed, and they do even today, and multiply that by the productions. So every single component is being produced, is being tracked, and being talked with each other. So you can analyze that data and you can connect it together, right? So by integrating the idea of Internet of Things and another concept called the computational physical process integration, which is CPS, they're able to come up with a system that is far more smart than earlier on. So now we have smart factories, which are defined as a factory that is context aware and it assists people and machines in the execution of the tasks. This is achieved by systems working in the background. These systems actually are able to fulfill the requirements based on the information coming in from the physical world. So if a component size is not right, the machine will adjust itself. If there are enough items being created of a particular type that need to connect it, that need to be attached to another piece of machinery, then those machines will coordinate the number of items being produced at the same time. They're communicating with with other systems where the drawings and the designs of the system that they're making are already present. So it's a communication of several things at the same time. So based on these given definitions, there is a concept of smart factories, and they will be filled up with the idea of Internet of everything instead of just Internet of Things. So even people around them, around these machines and products will be connected. So various technologies of networks are connected with it. So the idea is that the industrial internet is going to be created of sorts. This is the related concept to it. So what is Industry 4 in the German industry is referred to as the industrial internet in the rest of the world. So industrial internet has a broader focus because it talks about industries and application areas in various other areas as well. So the US government has been talking about advanced manufacturing and smart industries and completely automated factories where the machines are basically communicating with each other. Imagine an entire car being produced, or something as complex as a fighter jet being produced completely in an automated factory where every component is being attached and checked by machines that are communicating with each other. And again, when I say machines talking to each other, I don't mean in English. I mean communicating in machine language and communicating with what needs to be done as the next step. Now it talks about the research process and research method, which we can totally skip. So chapter 3 can be skipped because this is just talking about how they look for various research papers regarding this. Let's move to the chapter which is 4. Okay, so industry 4 design principles. So what exactly are the design principles that are talking about it? The first design principle is the interconnection. So machines, devices, sensors and people are all connected over the internet of things and internet of people and form what is referred to as the internet of everything. So you can look at this on page number 5. There's an actually a figure called figure 1 where they actually talk about the industry 4 design principles. So there are 3 or 4 concepts to it. There is the technical assistant, which is the virtual assistant, and physical assistant. Virtual meaning the machine based assistants, and physical being actual human being assistant. Interconnection, which means collaboration between all of these systems, between the people, between the machines, between the processes, as well as the maintenance of the various strict standards of quality, as well as the security of the people involved and the equipment involved, so that it doesn't cause any damage to the people around them, as well as the cyber security aspects, so that no intellectual property is stolen. And of course information transparency, because it can be the data that is being collected while all of these productions are happening can be used for analytics and for the provision of that information to authorities, to auditing firms, and to various other organizations. So this is what it talks about. It's about talking about human machine collaboration and machine to machine collaboration, where all of these are being worked together at the simultaneously at the same time. And imagine 3D printers working with design machines that are creating entire designs that people are working on. They're immediately going to be produced. If there are any flaws in it, they'll correct it. If they need to, the entire idea of a just-in-time production line can actually truly be implemented with such a smart factory, because they will precisely make every component with the principle of just-in-time in effect, because they'll be creating each component exactly when it's needed, not a second before, and there will be absolutely no wastage in such a factory, which actually follows these principles. So there's information transparency, because obviously there's so many objects and things that are connecting to each other. There are people as well as machines involved, so there needs to be a complete awareness and complete record keeping of it. For example, information system where virtual world are, for instance, there are documents, drawings that needs to be that need to be put into a information system. And for a physical world, obviously it's the location of a tool or a product. So these machines, such a factory would know where each component is in the physical world, so as to pick it up and attach it to another one and know precisely the dimensions, being able to measure them, as well as the people involved who are keeping an eye on the entire system and making sure that the process is going without any kind of issues. Then there's decentralized decision, which means that the interconnection of objects and people makes it easier for this place to be managed. So instead of everything happening at one central location and then the orders going on, every task is autonomous. Every machine is autonomous after it's given its instructions. So it's doing its job, doing its specific components. It's building a module or a component which will then be attached to the larger one. That's the decentralized aspect of it. Technical assistance. Now in smart factories of industry 4.0, the main role of a human shifts from operations of machines to actually just keeping an eye and strategic decision maker. They're going to decide how many items to produce in a particular day, or the number of products that need to be quality checked on a particular day, or to solve any kind of urgent issues when there are some machine breakdowns. Otherwise they're not even involved. They're going to be using their smartphones or tablets to just monitor the entire process, just to keep an eye. So they're just monitoring it, they're just observing it. They don't need to do anything. The machines are now going to be self-sufficient. They're managing it themselves. So those robots are just being supported. They no longer need to be actually watched or be operated by every single individual. So this actually saves us a lot of time, makes it more efficient, makes it more effective, and in the long run actually much more productive as well. So this is what it talks about. There's a whole case study on how people were actually convinced to the usage of it, which is again quite unnecessary, because it just talks about how they did it in the German industry. That's pretty much it. So I would recommend that if you are still unable to understand it, that you look at this particular diagram of a smart factory that I would show you on the screen right now, and that should help you understand what I mean by a smart factory. Okay, smart factory, internet, industry 4. Let me show that to you as an image, and that would be quite helpful for you to understand. So there are a couple of diagrams that you can look at to understand it better. Let's see if I can show that to you. Okay, so here's this one example of a smart factory, and you can see that talks about how innovation is happening. So they get employees and supervisors are able to move across the factory floor and access data wherever they want to of an entire factory that is actually completely smartly made. So they can stand here with a tablet and know what is happening in a factory. They can connect with various facilities. The entire industry is connected. There's a lot of efficiency because it's bridging the gap between the data center to control room, which is the data being collected, and they're looking at the designs and plans and everything. There's information coming in from the system, from what is actually being manufactured, so they can actually find common ground between the goals of the business and the actual manufacturing process happening. They can look at where the people are placed right now in real time and how they're doing their stuff. They could also manage the risk, the cybersecurity risk, as well as any kind of other health hazards or hazards when the machines are working, right? The people are actually free to do more strategic thinking, more strategic planning, because the factory itself is operating on its own. There's a lot of expandability possible. You can add and attach more elements to it. I've even recommended the games to you, 2 games actually, for precisely understanding this entire process. So if you get a chance, do definitely play them. Anyways, so connecting and collaborating externally, and understanding that you can actually connect with a lot of other people in other factories as well. So this is one example of it. Another diagram that could be helphelpful for you to understand is perhaps this one. So look at all of these possibilities, which is you've got smart sensors, you've got big data coming in, the 3 V's, velocity, volume, and variety. There's sensors being connected and talk to each other, the Internet of Things, there's artificial intelligence, there's cloud computing, data being stored, at various advanced algorithms being used. There's a lot of automation being used, and there's a predictive maintenance, which means that it can predict when a machine will break down so as to give you an update to so the machine basically tells you when it needs a maintenance function to be done. So this is how it's doing. This is just a summary again of the 4 industrial revolutions. Industry 1, 2, 3, and 4. 1 was mechanization, introduction of the steam and water power. That was in the 18th century. Industry 2 was the mass production and assembly lines using electrical power at the beginning of the 19th century, or rather the ending of the 18th century. And the Industry 3 was IT, the usage of IT and robotics eventually, going on from 70s and 80s onwards. And Industry 4 is what we are right now at, the smart factory or autonomous systems, artificial intelligence systems that are going to manage it on their own. So this is essentially what it is. There's this small little article that talks about the same thing. I will post the link of it in this particular video as well, and you can definitely go through it. It's a very short article, and this might actually make sense of what I'm talking about in a more general terms instead of just the German industry. So I hope this is useful for you guys. Thank you.